Hi, welcome to this episode. Today I like to improve the gantry of my machine. The X-axis right here, it doesn't really have a design flaw, but there is a problem with it. There's a piece missing that I've never installed. There are two individual Bosch profiles right here, or we call them in the US 80/20 profiles, and they're not connected with each other, so they're moving independently. And that leads to vibration and deflection of the gantry. In this case here on my machine, the X-axis. I have made a new plate. It is right here. And I like to show you the before and after difference. I've calculated out that the tool itself needs about 200 newtons to push through the material. That is the maximum my machine will see. So on Mother Earth, that's roughly 20 kilograms of mass, of load. And I have a simple setup here with a dial indicator that I like to show you before and after, and I also show you how I made the plate. Let's do it. Okay, let me explain what I did here. The dial indicator is set up on the nut of the spindle, and the spindle is fairly far down, and I have a hefty 1/2-inch shank router bit in there. Now, what I like to do is apply the 200 newtons or roughly 20 kilograms. And the way I'm going to do this, I'm going to hook the scale here at the router bit. And first of all, power it on, zero it out. And then I'm going to use just a wrench right here as a pry bar to get a bit more control. And we're at 12. This is upside down, of course. 13, 17, 18, 19, 19.7, 20. 0.17 millimeter. That's a lot. That's by far more than what I thought my machine would flex. Okay, same setup again, now with the plate installed, and let's see what happens. Oops, we have to turn that on. Five, 9, 11, 16 kilograms, 17, 18 kilograms, 19.7, and 20 kilograms, 0.13 millimeters we saw. So a bit of an improvement. Okay, let's do one further test. I've set up the dial indicator now to touch the back plate, the X-frame, and going to move again 20 kilograms of load onto the axis, and 16, 18, 19, 19, 20, 20.9, 26, 27. We only see about 0.03 of a millimeter on the dial indicator, and yeah, 0.03 of a millimeter. Well, that project didn't turn out the way I wanted to. Now, I was sure that most of the flexing would come from the Z-axis itself, from the Bosch profiles, and it didn't. So I remeasured everything one more time, and truth is that we have 0.02 of a millimeter movement on the lower rail, or on the lower side of the X-axis. There's zero movement on the top, which if you sync with the Z-axis doing like this on the leverage, that makes sense. Now next is I went ahead and measured the relation of spindle flex, or the movements that we see on the spindle nut, to the Z-plate, and that is where I found the highest amount of movement. So I think that I would have to install a Z-plate stiffener and possibly also have a look at the mount of the spindle itself. I'm going to do that next, and well, maybe you want to check out the next videos that I'm going to make. I hope I see you again. Okay, take care. Bye.